Hello everyone, welcome to AI Anytime channel. In this video, we are going to see that how we can inference the newly released Code Llama model through a new file format called GGUF. So GGUF is a new file format that will help us inference LLMs on commodity hardware. Okay. So earlier we were using GGML, GPTQ, etc. But now GGUF is new GGML. Okay. The reason I'm telling you this is because most of the frameworks and bindings are now going to support GGUF. They're already supporting it. For example, Llama CPP, Cobalt AI, and any other bindings as well that we earlier used, or now we also use for inferencing. Earlier we were using GGML format, but now we're going to use GGUF, which is a short form for again Georgy Gaganov's unified format. So it's now a unified file format that we're going to leverage to inference this 13B Code Llama model on a CPU machine. Yes, of course, when you use this, it will take little time, like for example 50 to 60 seconds, and also performance might degrade a bit because quantization, at some extent it loses information, but that's a myth anyway, right? So let's see how we can leverage this Code Llama 13B GGUF that you currently see by the block. Okay, I am on his Hugging Face repository, and you can see this is the model. So maybe I will use a 3 or 4 bit quantized. Let me show what I'm talking. So if you come on the home desktop, here in my project, and inside this I'm gonna go inside this GGUF. So you can see I have a 4-bit quantized model, a 13B instruct Code Llama, because we are going to have a natural language query to retrieve some kind of code information or some kind of codes, right? That's what we are going to do. Now the question is, why GGUF and not GGML? So Llama CPP, which is very famous in the LLM ecosystem, they have also started using GGUF, and you cannot inference any GGML model now if you want to do it from using Llama CPP. There are few benefits of in GGUF, as it's a unified file format. You will have a higher extensibility, right? You don't, if you see, all the .bin files have been replaced with .gguf file format. You can see it over here in this file and versions. That's one of the advantages. No more bin files. And earlier when we used Llama CPP, for example, they were very focused on Llama models, like the support were for Llama models. But after this single, or maybe single might not be the right word, after this unified file format, Llama CPP and other bindings, now they are supporting other LLMs as well. For example, Falcon or Bloom or RMKV, etc. Right? So there are more support through these bindings and frameworks when you want to inference LLMs, and that's where GGUF is going to play a role. Okay, it also helps you to customize your prompt. They have options of prompt customization, so you don't have to worry about some unnecessary parameters like GQA, right? Where we are using Llama CPP for Llama 70B or something, we used to look at parameters like GQA or rope frequency base, etc., etc., right? So that's also GGUF now takes care of it. You don't have to worry about those things. So these are some of the benefits. That's why we're going to use GGUF. Now let's come in this folder, guys. So you can see currently I am in this my VS Code. What I'm going to do is I'm going to create an app.py. So let's create an app.py, and here I'm going to write. So if you see my requirements, we need only two things. One is C transformers and the other is Gradio. Okay, you can also use this through Llama CPP, but I'm going to use on C transformers. And make sure that you are using this version, which is the latest version of C transformers, and this version supports GGUF model. I got it validated with the creator of C transformers, Marella, and I created an issue, and this has been confirmed by Marella that GGUF format support for Llama and Falcon models. You can see it over here in the latest version of 0.2.24. Okay, so please update your C transformers library if you have in your environment. Now let's go ahead and build a simple application and see if you are able to inference a 13B model through GGUF. So make sure that you are using the same version of C transformer, which is very important. Otherwise, you will get an error. And I'm not going to use a 7B model. I'm going to use a 13B model on my CPU machine, which has 16 GB of RAM, and it does have a GPU, but I'm going to inference this on a CPU machine to see if this works or not. So now import Gradio as gr, import time. Now let's use C transformers, and I'm gonna call this import. I'm gonna use causal LM. So let's use auto model for causal LM for text generation task. So I'm going to write a function called load LLM, and inside this I'm going to write, the first thing that we have to write is use this class called auto model for causal LM dot from underscore pre-trained. So this is what I'm going to do, from pre-trained. And so we have to give this file path name that you can see here that I have, Code Llama 13b instruct q4 km.gguf. And the next I'm going to do is, what is the model type of this? So for our model it is Llama, so I'm going to write Llama here. So let's do that. So you can use any other model as well which has a GGUF files already on the blocks repository, or any other Hugging Face repository as well. So our model type is Llama because we're using a Code Llama model here. You can see it's a 13b model. And what next I'm going to do is pass some inference parameter, not hyperparameters. So let's pass some inference parameters like max new tokens. So my max new tokens is, let's keep it 1096. And I'm going to have a repetition penalty to just keep a check on the repetition of the tokens. So repetition penalty is very important to use it for Llama based models. So repetition penalty, I'm going to keep standard 1.13 repetition penalty. I'm going to keep a temperature value as well. Maybe you can keep 0, but I'm going to keep 0.1 in this case. And that's it. So I'm just going to return LLM here. So this function helps us load this model that we have downloaded. So the file is available here on the blocks, files and versions. You can see this is the model that I'm going to use. That's called Code Llama 13b q4 kmggf, which is around 8 GB of size. So just multiply with 1.5, so it comes around 12 GB when you try to load and inference it. And I think that will be sufficient on a 16 GB RAM, right? So let's use that. So what I'm going to do next is write a function that's called LLM function, and inside this function we'll have, because we're going to build a Gradio app, so let's have for now message and chat history. Maybe I'm not going to utilize chat history here. I'll keep this just as a, maybe you can use this as a callback later on. But so what I'm going to do here now is I'm going to write so this function that you see, LLM function, where we are writing a message, which is basically a message and chat, because we are going to use a Gradio app. So here, first thing that we have to do is we're going to call this function that we have defined on line number 5. So let's call it LLM equals load LLM. And now let's have a variable called response. And this response, I'm going to call this message. So message that you see that we have is an input parameter. I'm going to call this message. Now I'll just have an output text. Or maybe you can just return. Let's have this response. I don't know what kind of outputs. Maybe we'll check that. Maybe we have to parse the output, or let's do for output text by now. If we have to parse it, then we'll parse like choice, etc. And like choices or text or something, we have to see what we have inside that. Now this return output text. Now the next thing that we have to do here is we're going to write some Gradio code. So let's define a title of our app. So what I'm going to do here, I'm going to call this as Code Llama or something. So let's call it Code Llama and 13b and GGUF demo or something. So we are going to, as I said, I'm going to inference a 13b model. And you can also define some examples, like some default examples. And the first thing that we're going to do is, like, these are some simple prompts that you want to use it to inference. So write a Python code to connect with a SQL database and list down all the tables. So all the table, this is my first maybe question. So we have to give a comma after this because it's a list. That was a good rhyming. Now let's write the write the Python code to train a linear regression model using scikit-learn. And the next question goes is explain the, or let's write for example, write the code to implement a binary tree implementation. So that's what I'm going to do in C language. Let's call it C language. And the next is, can you explain, let's write what are the benefits of the Python programming language. Okay, so these are my examples. That will be default examples. Now I'm going to use the chat interface class of Gradio. So they have a class called chat interface, which is a very high level API to use. You use that chat interface, you can see it says a callable function. So we can call that function. The first thing that we have to write is the function, and we're going to use that function that we have defined on top. That's called LLM function. So let's write LLM function. Now you're going to have a title. You can have title, descriptions, you can have examples, you can have a lot of other parameters, arguments over here. You can read it in their documentation. So this is not a Gradio video, but I'll give the link in the description for Gradio. Now examples. Okay, and now you have to launch. Maybe you can also keep it in a variable called demo, and then you do demo.launch, but I'm going to launch that directly. So now let's launch it. It's a function, and now it will help us launch. That's it. So what we are doing here, guys, that okay, we have C transformers, that is a Python bindings for C++, where we are loading most of the transformers based models, like you can using causal LM here. So what we do here, we say okay, load LLM. Okay, so we're using the class auto model for causal LM. Dot from pre-trained, we are passing our model file name, model type, some of the inference parameters, and returning that LLM. Now we are using that load LLM in the other function called LLM function, where we have message and chat history, and then LLM equals load LLM, response LLM message, and then your output text equals response, because we have to see that we have to parse it or not, what kind of output we are getting. And then we have a title called Code Llama 13B GGUF demo and some examples, and then just inferencing it. So let's do that. So what I'm going to do here is I'm going to open this in my terminal, and in this terminal I'm going to activate my LangChain environment. So conda activate LangChain. So let's do that. Conda activate LangChain, and now I'm going to just run this by doing python app.py. Let's do that. And once I do that, it says unexpected keyword argument. Okay, let's go back. I think that's not example, that's again examples. Yes, you can see. So now let's come back and here do that again. Now once I do python app.py, it says that okay, it's running on 786 node. So let's come back here and write 786 node. Okay, it's not doing, then we have to write 786 node. And now you can see that we have a simple interface, which is a chat interface given by Gradio with some chatbot like text input box, and this is where we'll see the result. We have retry button, we have undo button, we have clear button, which will clear all the records, and then we have some examples. So let's click on the first examples, write a Python code to connect with a SQL database and list down all the tables, and you can see it automatically populates this field. Now once you click on submit, it will take little time. So let's click on submit and see what we are getting here. So if you come back here, we're not getting any errors so far. So you can see the timer is running here. So what we are trying to do in this video, guys, now that we have a 13B model that we are trying to inference on a CPU through a newly launched GGUF. You can see over here, and GGUF looks very promising, and so what I'm going to do, I will pause the video here and I will come back once it gets completed. Okay, fantastic. So it took around 40 to 45 seconds, and you can see that we got our response. So our question was, write a Python code to connect with a SQL database and list down all the tables. So you can see it's using a library called PyODBC, and then creating a connection. So it has a con variable, connecting with the driver, which is a SQL server, giving you a local host, database, etc., trusted connection, passing all those authentication, etc. And you are doing a con.cursor, which is correct. It's getting the table, which is correct for table in table, sprint table. This is good. This is good enough. We are not passing. Maybe better to pass some prompt examples as well, but this is very good. So when you clear it, guys, then you can see it's cleared all the response from here, which is fantastic. So what we're gonna do next is, let's say, okay, write the Python code to train a linear regression model using scikit-learn. Now, what we are doing here again is we are asking one more question, and you can see the timer over here. Okay, the timer. Now let's wait for it because this is the last response that I'm showing you. But you can extend this Gradio app further. You can also use it for different other tasks, and all this on a CPU machine thanks to GGUF format. It's a new format that helps you inference LLMs on your compute limited hardwares, and this is really really powerful. And the results are good. We are using a 13B model on a CPU machine, but if you want to use a GPU, you can also look at, if you go back here on the C transformers, again, you have to make sure that you are using kubeless. You have to set the kubeless equals 1. You have to force set it. If you are on Linux, you have to do export. If you are on Windows, you have to do set. Okay, so please make sure that you are setting it properly when you are using Llama CPP or C transformers or Cobalt AI, etc. But this supports a GPU as well. So if you talk about C transformers, you have to basically pass GPU layers. You can see the GPU layers over here. You can pass it. You can start with 50 or 100 and then see if it's getting any error, then reduce the number over there for number of GPU layers. It totally depends what kind of VRAM that you have in your machine. And first you have to install C transformers with CUDA, and then we'll be able to use GPT-QA and GGUF models as well. Okay, now let's come back over here. You can see still learning. It took more than a minute for now, but because this might be generating a bigger, like a set of tokens, etc. But as I'm saying that you can also use C transformers for your GPU. You can see for CUDA, for Metal, you have to set it up differently, and for Llama CPP, you need kubeless, and you have to set that by force one. It's a little tricky to install, but there are so many resources that you can use it to resource, and you can look at different config parameters. You can look at these parameters if you are loading this model, the LLMs through C transformers. You can pass GPU layers. You can also pass the context length, which only supports by now Llama MPT and Falcon models. Okay, it's taking a little time. We'll wait for it, guys. And I'll give the link in the description. If you come to block Hugging Face repository, you can see all of his models now. Okay, he's also quantizing it and making it to the GGUF format. You can see the widget coder, which really performed well on the human eval recently on the leaderboards as well. So all of these models are now being converted to GGUF format. You can see all of this Code Llama, this Aeroboros, and all of these models, okay, which has been converted to GGUF. You can see all these models, Code Llama from 7B, Python GGUF. This might be a little faster, but if you use this, the performance might degrade a bit. You might not get the result that you are looking for. So it's better to use a 13B model and set it up on in your infrastructure and try to see if you are able to generate the responses. And the code will be, this entire code will be given on the GitHub of AI Anytime's GitHub. I will share the link of repository in the description, guys. Okay, now hopefully it's still taking time. You can see it took more than 2 minutes for this query, but this is what it is. If you want to use it on CPU machine, you have to basically wait for it, guys. And you can see there's no logs also. Maybe you can do verbals to put it over here. So let me do one thing. Maybe I'll just pause the video again and I will resume it once it gets completed. Okay, fantastic. So it was fast. I just paused the video and I got the result. So you can see it importing the libraries. It also comments it. You can see import pandas and scikit-learn, because we are using scikit-learn here. So we're using sklearn import datasets, and it's reads the Boston dataset, a very classical machine learning problem. it uses linear regression, some evaluation metrics like MSE and R-square, and it has a train test splitter and loads the data, split the data, get some values, etc., etc. Then model.fit, model.predict, and also evaluating the model. Fantastic, right? So it's really good when you use the 13B model. We get some good results, and you can see it takes a little time depending on the prompt that you are making. For the first prompt, which was on SQL connection, it took around 45 seconds, but for this query it took around 3 minutes, so more than 3 minutes. So it depends what kind of machine you have and how are you running this and what kind of prompt you are making. But you can inference a 13B model on CPU through a GGUF. That's what I wanted to show you guys, through this video. Okay, and so that's all. You can go ahead and take the code, extend it further for your use case or whatever task that you are working on currently. If you want to use a coding specific LLM, I will recommend using Code Llama, Star Coder, or Widget Coder as well. Any one of these will be fine enough to go ahead and work on it. Okay, and so that's all, guys. If you have any thoughts, comment, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. It's available on the YouTube banner. Okay, and if you haven't subscribed the channel yet, please do subscribe the channel. If you like the video, please like the video, hit the like icon, and you can also go through my LLM playlists if you want to work on projects through a bit on top of LLMs. Okay, that's all for this video, guys. Thank you so much for watching. See you in the next one.